today we're going to be covering lesson 8-2. This is the final lesson for unit 1. So what we're going to do today is writing equations of a line that is parallel or perpendicular to something. So make sure you have your Springboard books open to page 92, and let's get started. So we're back at the diagram with the skate ramp, okay, on the coordinate plane. So they're saying the equation of the line BD is y equals negative 2/3 x plus 4. So let's kind of pinpoint that line BD. So here's line BD. So they're giving you the equation of that line. They want us to identify the slope and the y-intercept of that line. Well, they gave us this equation in slope-intercept form, right? Y equals mx plus b. So remember, anything that's in front of your x, that's your m. That's representing the slope. And the number that is added or subtracted on the end, that's the y-intercept. That's the b. So in this case, the b here is 4, positive 4. And technically, since that's a point, we should write it as 0, 4. And then the slope is the value in front of the x. So in this case, our slope is negative 2/3. Okay? So we're going to use these numbers moving forward. So we made conjectures in our last lesson about parallel and perpendicular lines, right? So we want to use those conjectures to find the slope of the line JM. So let me mark JM for us so we can see where that is. JM is there. So if we look at lines BD and JM, what kind of lines would you describe those as? Hopefully you said that those look like parallel lines, right? They are not intersecting. They're running side by side. If we find their rise over run, I'm sure we're both going to get that they're negative 2/3. So we don't necessarily have to use the formula for slope because we learned in the previous lesson, if those lines are parallel, okay, parallel lines have the same slope, right? So if the slope of BD is negative 2/3, it's the same slope for JM. They'll have the same exact slope if they are parallel. And again, you could do the rise over run to check that, but that's just what it is. So now we're going to find the y-intercept for JM. So let's go back to this picture. JM crosses, here's your y-axis. So where it crosses the y-axis looks like about there. So if we count up, that looks like it's at 6. So in this case, the y-intercept is 6. So use the slope in our y-intercept now to write the equation of that line. Again, using slope-intercept form, go ahead and plug those numbers into your equation. And you should get this. Y is equal to negative 2/3 x plus 6. Okay, y equals mx plus b. Okay, number 4 says JM is perpendicular to RJ. So let's find RJ on our graph. RJ looks like it's right here. And it's telling you that those are perpendicular. Okay, it says if RJ is perpendicular to JM, identify the slope in the y-intercept. And then write the equation. So remember, if two lines are perpendicular, that means their slopes are opposite reciprocals. I'm going to abbreviate there. Opposite reciprocals. So if the slope of JM is negative 2/3, its opposite reciprocal would be positive 3/2. So we flip the fraction and we flip the sign. So that would be our slope there. If I peep at the graph there, it looks like it has the same y-intercept. So the y-intercept would also be at 6. So if I wrote this equation then, it would be y equals 3/2 x plus 6. So again, parallel lines, if we look at them and compare them to each other, the equations are going to have the same slope. Okay, if they're perpendicular, their slopes are going to be opposite reciprocals. I think that's the explain here. Okay, are they perpendicular? Yes, their slopes are opposite reciprocals. Okay, let's move on to the next set of questions then. The skate park will also have an angled grind rail. The drafter has drawn this picture on the coordinate plane. So the drafter has already drawn line N, okay? And they need to draw a line P so that it's parallel to line N and passes through this ordered pair, -2, 3. So on here, line N is this black line here, and I'm using this notation to say the slope of line N, so M of N. The slope of line N, I'm telling you, is 1/8. Okay, so they want us to find the slope of line P. Well, the key word here is they wanted that line to be parallel. So if the slope of line N is 1/8, so is the slope of line P. Right? So next we're going to go through the process of writing the equation for this slope. So what is the equation of line P written in point slope form? So if you remember from our notes the other day, or from this little connect to algebra box, here is point slope form. Y minus y1 is equal to the slope times x minus x1. Remember, your ordered pair is going to be x1, y1. That's what that's for. X and y, the plain x and y are our variables. So let's plug in what we know. We know it's y minus the y1. Our y value is 3. Equal to the slope we had was 1/8. X, when we have minus a -2, that's going to turn into +2. So here's our equation in point slope form. So next what they want us to do is write this equation in slope intercept form. Y equals mx plus b. So to do that, I just need to clean up this equation a little bit, do some distributing and getting y by itself. So I'm going to start by distributing that 1/8 to the parentheses. So that's going to give us y minus 3. So 1/8 times x is 1/8 x. Then we have 1/8 times 2. So if we do the work on the side here, 2 goes into 8 4 times. So that's actually going to give us 1 times 1 on top, and then 4 times 1 on the bottom, so 1/4. Now, if fractions are not good for you, you can always use a calculator, right? If I have 1/8 and I times it by 2, if you hit math, enter, it should give you your answer as a reduced fraction. Okay. The last step then I would just have to do is add the 3 to both sides. I'm just going to do that in my calculator here. I'm going to take 1/4 and add 3. My calculator is already using fractions, so 13/4 would be that answer. So if we add 3, we're going to get y is equal to 1/8 x plus, my calculator told me it was 13/4. You could also write 3 and 1/4 if you wanted to, but there you go. Okay, so now if we sketch P on our drafter's plane, let's see, 2, -2, 3. So there's line P. So as you can see, they run side by side, parallel. They should have the same slope if I actually calculated it. Okay. All right, let's jump to the next page here. Similar idea, except now the drafter needs to draw in line Q so that it is perpendicular. So line Q is going to be perpendicular to our original line N. Okay, and they're telling us a point that passes through, -9, 7. So remember, the slope for line N was 1/8. So if we need to find a slope of a line that is perpendicular, that means I have to do the opposite sign. So in this case, it's going to be negative. And we have to find the reciprocal of 1/8. So 1/8, the opposite would be 8/1, which is just 8, right? So that's the slope of line Q. So remember, if they're opposite reciprocals, their product should be -1, which is what we have here. So if we write the equation for line Q in point slope form, so they gave us the point they want us to use, -9, 7, and now we know the slope we need to use, so I'm going to go ahead and plug that in. So this is our equation in point slope form. So then to turn it into slope intercept form, we would just have to distribute and clean it up. All right. That's going to give me -8x minus 72. So then if I add 7 to both sides, you get y equals negative 8x minus 65. Oops. For some reason I'm having real issues drawing an 8 there. That's negative 8x. Let me just rewrite that because it's going to bug me. Minus 65. Okay, and then they want us to sketch that on our picture on the previous page. So I'll just show you what that looks like really quick. But there's our line Q. Okay, so we have line P, line Q. So we have our perpendicular line and our parallel line. So when we're writing equations for parallel lines, we use the exact same slope, plug it into the point slope form, and then we clean it up to get our slope intercept equation. If we're doing perpendicular lines, we're going to make our slope the opposite reciprocal, and then plug it into point slope, clean it up to get slope intercept. So we're just going to end the lesson here by doing these kind of 2 practice problems. Now these are kind of just more straightforward problems, not so springboardy. So number 16, they want you to write an equation of a line that is parallel to this equation. So if they're parallel, you need to find the slope of that equation and figure out what it means to be parallel. Okay, so if this slope is negative 3, it's the number in front of the x. So if it's a slope parallel, you're going to use the same slope. So now you have a point and a slope. You plug it into point slope form, clean it up, and give me the answer in slope intercept form. So try 16 right now. Okay, if you got 16 right, you should have got negative 3x plus 26. Okay, last one, number 17, they want you to write an equation of a line that is perpendicular to this equation. So look at the slope of that equation. It's 1/4. So if you have something that is perpendicular to that, it means you're going to use the opposite reciprocal. So positive 1/4, the reciprocal would be negative 4/1. So now use that slope and that point, write the equation that it goes with that line in slope-intercept form. Okay, here's what the final answer should be. Negative 4x minus 4. So if you didn't get those answers, just double check that you use the right slopes. Okay, and then just double check your arithmetic, but you probably got it right. Okay, so that is how we write equations. So again, find the slope you need, the point you need, plug it into point slope form, and then simplify it down till you're in slope intercept form for your final answer.